So in this problem, we need to express each of the following sets in tabular form. So here we have the first set A that's expressed in the set builder form. Let's try to read the given set. We have set A containing the elements A, N such that N belongs to the set of natural numbers. And we have the condition A(n plus 1 equals to 3 times A(n) with the value A1 equals to 2. So that means we'll start with n equals to 1. Since n is a set of natural numbers, so n can take the values 1, 2, 3 and so on. So we'll start with n equals to 1. So when we have n equals to 1, then we can use this condition A(n plus 1 equals to 3a, and we can replace n value with 1. So that's going to give us A1 plus 1, that will be equals to 3a1. So that means we have A2 equals to 3 times A1. Now we are already being provided with the value of A1. So A1 here is equals to 2. So when we substitute A1 with 2, so we get 3 times 2, which will be equals to 6. Now that means A2 that is equals to 6. Then let's consider n to be equals to 2. So when we have n equals to 2, we'll use this condition again. That gives us A2 plus 1, so that will be equals to 3 times A2. So we have A3 equals to 3 times A2. So A2, we've already obtained this value, so that's 6. So we have 3 times 6, so this will be equals to 18. Then we will consider n equals to 3. So n equals to 3 corresponds to A4 equals to 3 times A3. Since A3 is 18, so we have 3 times 18, which will be equals to 54 and so on. So that means we have the set A, which contains the elements an. So when n equals to 1, so we have A1, we already have the value that's given to us, that will be 2. So that's the first element. Then we have n equals to 2, and that's going to give us the value A2. So we have found out A2 equals to 6. Then we have A3 will be 18, and then we have A4, which is 54, and this is going to continue. So that means A contains all of these elements 2, 6, 18 and 54 with the conditions that n belongs to the set of natural numbers. We have A(n plus 1 equals to 3 times A(n) and A1 equals to 2. Now let's do the second one. So here we have set B, which contains the elements A(n) such that n belongs to the set of natural numbers. We have A(n plus 2, that's equals to A(n plus 1 plus A(n) with A1 and A2 having values equals to 1. So here we are already being provided with A1, and we have A2 value that's equals to 1 as well. So let's do one thing. Let's take the first value of n equals to 1, because we know that n belongs to the set of natural numbers and can take the values 1 starting from 1. So when we have n equals to 1, so using this condition, we have A1 plus 2, so this will be equals to A1 plus 1 plus A1. So that means we have A3 equals to A2 plus A1. Since we are already being provided with the value of A1 and A2, then let's substitute it. So we have 1 added to 1, that will be equals to 2. So that means A3 equals to 2. Fine. Then we can take n equals to 2. So n equals to 2, that corresponds to A2 plus 2. All we have to do is substitute this value of n with 2. That will be equals to A2 plus 1 plus A2. Now that means we have A4. So A4, that's equals to A3 plus A2. So what's A3? A3 we obtained, that's 2. A2, that's equals to 1. So we have 2 plus 1, so that will be equals to 3. Let's find out one more value. So for n equals to 3, we have 3 plus 2, that will be 5. So A5 will be equals to A4 plus A3. So A4, that's 3, and A3, that's 2. So this will be equals to 5 and so on. So that means we have the set B, which contains the elements an. So if we replace n with 1, so we're going to get A1. So A1, that value is equals to 1. So when we take n equals to 2, then A2, that's 1, but 1 is already, we have used up 1, so we don't have to write it again. So we will go to n equals to 3. So A3 corresponds to value 2. Then we have A4, so that's 3. Then we have A5, so that's 5, and this keeps on going. So this is the set B expressed in the tabular form.